Hello, everybody. Good morning. We are working in section 4.3, talking about rotations. So we're going to start by reviewing our schemas that we talked about yesterday, which was on opposite schemas. So we talked about opposite schemas. We had a few different examples. The main idea is that objects that are opposite each other are the same distance from a certain point. So, how do we want to say that? We can say opposite objects are the same distance from a middle point. How about that? That should kind of sound like midpoint. It should kind of sound like segment bisector, that kind of thing. And we had a few different examples yesterday. We talked about temperature. So if it's 0 degrees out and one town is 6 degrees warmer and another town is 6 degrees cooler, we know the temperature of those towns then, 6 degrees and -6 degrees. But the important thing is just to note that they are the same distance away from the center as each other. So they've got the same magnitude, really. Now, moving on to today's stuff, we start off with a nice little typo here. It says a digital clock shows 12-hour times. It's supposed to say an analog clock. And if you look at the clock at the back of the room, it's an analog clock. But it says after 15 minutes, the minute hand moves a quarter of the way around the clock face. If the time is 4 o'clock, what time will it be after the minute hand rotates 3/4 of the way around? So clocks, I know we probably have varying degrees of familiarity with them. I drew kind of a bad one here, but 12 is always at the top, 3 is always at the far right, 6 is at the bottom, 9 is at the far left. And then you can kind of fill in those middle values. We're not going to use them much today, but that's okay. So if it's 4 o'clock, that means our hand would be pointing at 4. So that's the short one. So the short hand is pointing at 4. And then the minute hand, that's the longer one, is pointing at 12. And they're saying it rotates 3/4 of the way around the clock. The minute hand does. So just remember, clockwise is always going kind of around to the right. So if it turns 1/4 of the way around, so from 12 to 3, that would be 15 minutes. If it went another quarter, that would be down to the 30-minute mark. And then another quarter would bring it out here to the 45-minute mark, or the 9. So if that minute hand starts up here, it moves 3/4 of the way around, 45 minutes have passed. So what time would it be? It'd be 4:45. Alrighty. Next up. It says a video game turret rotates in 90-degree increments. It is facing east. Each press of a button rotates at 90 degrees counterclockwise. After 2 presses, which direction will it face? So I'm going to do this. I'm going to make a little compass here, north, east, south, west. And we're going to say we press it once. And we're going to see where it is again. So I'm going to give myself another little compass here. And this will make a little more sense here in a moment. So we pressed it. We have another compass. And then we're going to press that button one more time. I'm going to give myself a final compass down here. North, east, south, and west. So we start off with this turret facing east. And when you hit the button, it's going to rotate 90 degrees counterclockwise. So it's going to rotate 90 degrees that way. So once we press that button, it's now going to be facing north. And if we press it again, it's going to rotate 90 degrees again, counterclockwise. So we're going to end with it facing west. So we would end with our turret facing west. All right, so talking about schemas, These are a type of cyclical or rotational schema, and it's used when a quantity moves repeatedly through a fixed cycle and returns to the start after completing a full loop. And it follows this pattern of a starting position plus some number of quarter turns or 90-degree turns, and it ends at a new position within the cycle. So let's talk about graphing. We're going to talk about rotations specifically today. And this has all to do with cycles. So a rotation is a transformation in which a figure is turned about a fixed point called the center of rotation. And rays drawn from the center of rotation to a point and its image form the angle of rotation. Now, we are going to be operating almost exclusively with counterclockwise rotations, okay? They want us to start off with the rules for each of these rotations. So we're really going to work with 90-degree, 180-degree, and 270-degree rotations. And if you've got that little half sheet thing from yesterday with all the rules on it, this box is going to be sort of our guide here. So if they want us to rotate 90 degrees, we're going to start at xy, and that's going to take us to negative y, x. If we rotate 180 degrees, we start at xy. That's going to take us to negative x, negative y. And rotating 270 degrees, we start at xy, and we're going to go to y, negative x. All right, let's look at an example of that. It really ends up operating a lot like the stuff we did yesterday, but with a couple little tweaks. So this says write a rule for the transformation, question mark for some reason. Then graph triangle ABC with those vertices and its image after a 180-degree rotation about the origin. So our rule here, we've already written it down actually, starts with xy, and it goes to 180-degree rotation, ends up at negative x, negative y. All right, so they give us points A, B, and C. They said A was at 3, 1, B is at 3, 4, C is at 1, 1. And if we're rotating 180 degrees, our A prime and B prime and C prime are all going to follow that rule. So X and Y end up staying in the same location. We just changed the sign on each of them. So 3, 1 is going to become negative 3, negative 1. 3, 4 will be negative 3, negative 4, and 1, 1 will become negative 1, negative 1. So let's see what that looks like. So 3, 1 is right there. 3, 4 is here. And 1, 1 is there. So that's our A, that's our B, that's our C. All right. Now, that was our pre-image. So for our image, negative 3, negative 1 will be here. Negative 3, negative 4 will be down there. And negative 1 will be there. So that would be our A prime, our B prime, and our C prime. And you should notice, it looks like it rotated all the way around that center. It just kind of spun around the middle. If I rotated it 180 degrees again, it would end up right back where it was at the beginning. So we started in the first quadrant, moved through the second quadrant, ended up in the third. And if we rotated it again, which we're not, we're just going from here to there. But if we rotated again, we would go through that fourth quadrant back into the first. Next up, we've got example 2, which unfortunately got kind of cut off with the printing here. But it says, write a rule for the transformation, question mark. Then graph segment RS with endpoints R, which is at 1, negative 3, and S, which is at 2, negative 6, and its image after a 90-degree rotation counterclockwise about the origin. So let's start off with that. So we want our rule, and if we're rotating 90 degrees, we're going to start with XY, And you can use your little half sheet. Rotating 90 degrees takes us from xy to negative yx. So it's going to go negative y, x. And our points were R and S. So R is at 1, negative 3. S is at 2, negative 6. And we could plot those. 1, negative 3. So our R is right there. And S is at 2, negative 6. That's our segment. And we're going to rotate this 90 degrees counterclockwise, so about the origin. So we're going to rotate around the origin. So we're in quadrant 4 right now. We're probably going to end up in quadrant 1, I would guess. But let's see what that does mathematically. So using our rule, we've got our pre-image, right? Pre-image, we're trying to get an image out of it. We start at xy and we go to negative yx. So I notice my x's, the signs don't change at all. The x just moves from that first position to the second position. So this x of 1 is going to become my new y. And we could do it down here too. That 2 on the s is going to become the y prime coordinate for s. And I should note here, this is going to be our r prime. That's going to be our s prime coordinates. Now the other one, that y, our second value here, that y is going to become the x in our new coordinate, and I'm going to change the sign. So negative 3 is going to become positive 3 there. Negative 6 is going to become positive 6 there. All right, now let's plot those. So we've got 3, 1, that is our r prime, and we've got 6, 2, that's going to be our s prime. Bam, perfect. It looks like it rotated exactly 90 degrees about the origin. All right, we'll make this last part quick. So a figure in the plane has rotational symmetry. This is a bit like line symmetry from yesterday. When the figure can be mapped onto itself by a rotation of 180 degrees or less about the center of the figure. So here we're talking about the center of the figure. So I think the easiest way to think about this is look at that first image they give you. If I rotated that 90 degrees, it would end up looking like that. Looks exactly the same, right? If I rotate it 180 degrees, it would look just the same. So whether it's 90 degrees, 180 degrees, whatever, you get the same thing. If I took that image and rotated it half of 90, so if I rotated it 45, notice that picture does not look the same as that one. It's kind of tilted. So that particular image would have 90 degree and 180 degree rotational symmetry, but not 45 degree rotational symmetry. And down here we have a couple more examples, and I've printed out a couple comparisons here. So, and you can always just sort of put your pencil at the center of a shape and try rotating it. But if we take that shape, I of course can't do it here. But if I take that shape and I rotated it, let's try this. 90 degrees, it would look like that. 90 degrees more, it would look like that. So I just took that shape and rotated it 180 degrees, and it ends up looking exactly the same. Let's look at that trapezoid down on the end. All right, if we start with that, and I rotate it 90 degrees, maybe, no, of course, that's not going to look the same. If I rotated it 90 again, so a total of 180 degrees, nope, doesn't look the same. So that one is not going to have rotational symmetry. All right, let's talk about that octagon right there in the middle. If I take that shape and rotate it 90 degrees, it looks exactly the same as the original. Or 90 degrees again to give me 180 degrees, looks exactly the same. And in fact, if I take it and rotate it half of 90, so if I rotate it 45 degrees, it looks the same. So 45 degrees again gets me there, 45 degrees again gets me there, 45 degrees again gets me there. So rotating it 45 degrees actually ends up mapping onto itself. So this shape is going to have multiple rotational symmetries. It's got 45 degree symmetry. I can say, what's 45 plus 45? That's 90. Plus 45 again gives us 135 degrees. Plus 45 again gives us 180 degrees. So it has all of those different types of rotational symmetry. So that is it for rotations. Try the homework out and make sure you use those rules. They're super helpful. Have a good day.